Alright, so now let's talk about Pyro solver and which settings do we have here. Okay, so this is my left and this is my right. I'll call it left and right. Okay. And yeah, I'll place it like this just to make it more logical. So, okay. First of all, we have a simulation tab here, combustion. Well, in simulation we have basic parameters of the simulation. On the combustion, this is a model which control each aspect of simulation. Shape is affecting the final look. Relationships is kind of advanced, and I'm not gonna cover it in this lecture. And advanced tab is about OpenCL acceleration and deep control of the field. So I will talk about simulation, combustion, and shape, and a bit of advanced. All right, so first of all, time scale. This is like a local scale of the time, not like this. Here is a global one, and here is local. So I can set it to something like this and play my simulation, and this will behave differently. So this looks like it's fire under some heavy pressure or gas under pressure. Okay, temperature diffuse is telling how much the temperature will blend with environment temperature. So currently it's 12.5% per frame or per second. And this works like a Gaussian blur, so this is like a pixel sampling. So, and each second this will blur to 12%. All right. So I will set this one the same. So default flame, and something goes wrong. All right. So the issue was that my Pyro box was offsetted like this, so therefore it doesn't work. Okay, so now I have two the same simulations, and now let's change some parameters. So temperature diffuse I will set to something like this, and you see that temperature is falling down really fast, and therefore the simulation become really like weak. So here is the temperature field, and here is also a temperature field. So like this. So you can see the difference. This one is really blurred, and therefore simulation there is not so much fire. All right. So let's bring it back. And I can set the blur a bit smaller. and again it's affecting the simulation really hard. So all of these parameters is really sensitive, and changing to a small number can change the whole simulation a lot. So I will bring it to default value for this. Cooling rate is basically how much temperature in percentage the simulation will lose per second. So now it's 0.8, and the value is from 0 to 1. So currently each second we will lose 80% of energy. Okay, this is default, and if I set to something small, so we lose very little amount of energy per second. You can see that flames goes really high, and yeah, there is like a pulsation, and yeah. And if I bring it to 1, so we'll lose 100% of energy per second. Yeah, something like this. So the flame is kind of weak and very little. And smoke is really subtle here. All right. And it was 0.8. So as you remember, the bold values isn't default, but here it's default for this preset. So just bring it back to keep it the same with this solder. All right, and viscosity tends to make a flame like slow and viscose, which is kind of strange. You see, it's like a jello, or I don't know. It looks really unnatural, like in slow motion. Probably might be useful for some close-up slow motion flame simulation. Buoyancy lift is a buoyancy force. So if I made it really huge and unclamp my firebox, then we already saw the result of this. So the simulation goes really fast up, kind of turbulent, and somehow interesting. So yeah, well, this looks like a cigarette smoke, but this is too fast. So probably if I add a bit of viscosity, and we'll play this. So you see the flame become very smooth and not turbulent. Oh, that's actually not what I was expecting, but maybe this might work. Sure. Right. So, and here I can set the direction of buoyancy force. This is vector math. So if I set 10 here and 1 here, this will move mainly in the x direction, which is here, and a bit up. So like this. Okay, let's do it the negative way and a bit more up. So now it simulates a bit of wind. Yeah, but the flame is really smooth. So, all right. So let's bring it back. 1, 20, default value is 4.5. Okay, Next tab is combustion. Okay, and in combustion tab we have enable combustion checkbox. If I turn this off, the simulation will stop. So I bring it back. Ignition temperature is a threshold for temperature field value. So once if the field value is lower than this, the ignition will not happen. So I set something high, and the fuel is here, but no ignition happens. If I set it to something low, the ignition starts. Stop. Alright, revert to default. Burn rate is tells how much fuel I burned per second, and this is from 0 to 1, so now it's 90% of the fuel will be burned in each second. And if I set to something low, then not much fuel will be burned. So here is 90% and here is just 25. Okay, and next parameter is fuel inefficiency. It tells how much fuel will be removed from a fuel field after it's burned. So now 20% will stay in the scene, in the field. So if I bring it back to 0.9, and now 100% of the fuel will stay in field. So it's not decreasing, it just burns, and yeah. And next parameter is temperature output. It tells on which value temperature field must increase after each fuel unit consumed. So once fuel efficiency is 100%, so all fuel which is burned are staying in the scene, then a lot of temperature increasing happens. So if I set temperature inefficiency to the low value, so almost all fuel are burned and removed from field, then the temperature growing not so fast. Well, it's almost like it's almost like default value. All right, so 0.2. And temperature output, as I told, it's a value on which the field will grow up, each fuel unit consumed. So if I increase it, after fuel consumption, the temperature grows up, and you see this flame leaks. It's become more interesting, very turbulent. Yeah, but also it's going up really fast. It's like buoyancy force is increased, however I haven't touched it. So the higher temperatures, the faster it goes up. This can be suitable for gasoline explosion when since gasoline is burning really well, then it just explodes and a lot of temperature output happens. So okay, and gas released, this parameter controls how fast the simulation will expand. So now it's 14, and if I increase, then you see a lot of gas emitted to a scene, and it expands really fast. Yeah, like this. And if I set it to something low, not much gas presented in the scene, and this is just saddle burning. Yeah, like so. Alright, let's bring it back to 14. Flame height, it's scaling factor for flames. So if I set it to high value, my flame will be kind of scaled. You see it's way more flame, even if the temperature field and the heat field are the same. And the cooling field controls, it's like a ramp parameter, and it controls how fast the temperature will drop down. And here is the fastest temperature drop, and it gets slower and slower. And here is, this axis is density. So the less dense the field, the faster temperature drops down. So this will be like a center of the flame. Okay, and so it's like here, and this one is like here. So if I set the ramp parameter like this, so a lot of energy will be thrown away in the beginning, like so. So it's cooling down and turns into smoke. Oh, I forgot to bring this back. Okay, so let's play again. So yeah, now there is not much flame, but a lot of smoke, just because all my heat field is cooled down like this. And I can set something like that. I don't know, I'm just trying. So cooling will happen on this curve, which is probably unrealistic, but it gives some result, and sometimes it might be useful. So it just gives you a lot of control about what's going on here, and that's how Houdini works. A lot of control. Okay, and next up is smoke. Here we can emit smoke, or we can turn this off, and we'll have just a flame, and no flame here. Probably I need to increase it here. Nope. Well, as it's known, there is no fire without smoke, or no smoke without fire. So let's leave it on, and I can just set the smoke amount to a very saddle value, and again, no flame. Okay, little flame here. Well, a lot of flame, but no smoke. So, all right. And also here is a heat cutoff, and it basically tells at which value of the heat field the smoke will be emitted. So if the heat field have the value 0.2, then or smaller, then we'll get the smoke. So if I set to 0.9, the smoke will start to appear earlier, because the value is 0.9. Oh, and I need to bring smoke amount back so we can see what's going on. So now there is almost just smoke, because it cuts off the value and turn it into smoke. And blend amount is just basically blends smoke and fire, and it's like a fall off. Yeah. So if I set to high value, it will be really smooth blending. Well, it's kind of hard to see it here because we use 2D and this is just viewport representation, but this is just blend. Right? And also we can create a dense smoke for example, this used in the Volcano preset. And I can decrease smoke amount. And if I turn this off, I will get the basic smoke. Yeah. All right. And as a source, currently it's using heat field, which is the same with flame. But I can set it to burn, and heat cutoff and blend amount become unavailable because they can work only with heat field. Okay, so let's bring it back to heat. And next is gas. And this one defines how much the gas will affect the flame and burn process. And if I set the flame contribution to high value, you can see that the gas which has been emitted by burning the fuel is affecting the flame. All right. Temperature field. I can turn on this, so flame will affect the cooling rate. And you see the whole simulation get hotter. And there is the whole bunch of parameters, which is allows us to control the flame behavior and by temperature field. And fuel and vect fuel, well, turning on this option forces the fuel to be like advected, and the whole simulation become more unstable and really rapidly growing. So now we have just kind of small value, and if I set to a bit higher, this will lead to this. It's like uncontrollable nuclear explosion. So I normally use this off because this become really unstable. All right, next up is shape. And here we have few parameters turned on. And I will turn off 2D. And probably turn off this, so I don't need to simulate this. Okay. Now let's talk about shape. This will be kind of hard to show because it's necessary to have a higher resolution of simulation, so I will increase it, but simulation will be slow. But yeah. Alright, something like this. And I will create a light. And we'll make a flame like this. More shadow, because I need to show this little details here. So After making it more dense, it starts looking way better. Something like this. All right. So now let's talk about shape. Dissipation is, well, all these parameters is pretty self-describing, and um, it's easier if you read it by yourself, because my explanation will be kind of bad because I'm not a native speaker, and these parameters is kind of hard to describe. So the smoke has just started dissipating, and the huge value will do it like this. So you see, if when I'm changing the scroll, so the higher value, the faster it will disappear. All right. Disturbance is it creates a huge curl. It's like a noise. So if I set a huge disturbance, something like this, and we'll play the simulation, you can see that it's really noisy. And the nice thing about it that this disturbance is not affecting the flame behavior, general behavior. So too huge disturbance is not nice. And all of these parameters, you need just try and find something that fits your needs. So the flame is really noisy. Smoke. Shredding is for little curly noise, and it creates streaks and licks of fire, and the small value will make the flame really smooth and like smoky. Alright, while the huge value will make it really noisy. It's like all these little coral smoke things. But again, to be able to see this these things, you need to have a really high res simulation, because now this is viewport and not really high res. I will try to render it. So yeah, you see it. It looks bad. So all right, and all right, let's bring it to default value. Oops, unlock and revert to default. All right, sharpening. It's well, it's sharpened the little noisy things. If I simulate a bit. This is like post-processing for flame, but this must be turned on in the beginning. Well, again, this is really hard to see it now. Okay, I will turn off sharpening, but turbulence, it's create a huge turbulent noise for simulation. And yeah, you see that it's growing a bit different, and all these coral things. The confinement is boosting vortices. So if there is some, this will make it bigger. And you just need to be careful, because huge values can make the simulation unstable and just explode everything. For example, like if I do it now, let's say something like this, it should be really high for this. So yeah, You see there is almost no details because everything is blurred and the whole simulation is destroyed. And each of these parameters is making simulation slower. So by default, it has only this three turned on, and this is kind of enough. And this three should be turned on when you're ready to make a final decision. And in addition, each of this parameter has on top here, and here again we have ramp parameter, which allows us to define the really fine behavior of the simulation disturbance. So here we can set field, which field we want to disturb. Currently it stands to velocity, but for example, if I set to temperature and my disturbance is turned on, yeah, you see this huge plumb. Yeah, simulates really nice. And I can set the block size, for example, to something huge, and yeah, it creates a different plumb. So any of these parameters is really affecting the behavior. So there is almost no parameters which do nothing. And small value like this. Yeah. Well, we can probably you can see this slices here. This is because of low res. So, and we can take a control field, for example, heat, and do something about it. Yeah. So if I bring it back to velocity, the behavior will be different again. It's really subtle difference, but it's here. Shredding and temperature threshold. After which value of the field the shredding will be started. So now you see the shredding begins really early. And again, all the parameters to control it. The same about sharpness, turbulence. Well, those three are inactive now because it's turned off here. But if I turn on the turbulence, for example, I can set the swirl size. Yeah, and you see how different the whole simulation become. It creates a really huge swirls, which is kind of really interesting and nice. And yeah, you see. So it's really cool for explosion. And the pulse length, for example, let's do something like this. Well, this probably will explode everything now. It's the pulse length is defined the length of the impulse, deformational impulse. And now probably the swirl size is too big, and therefore it's not affecting. Yeah, it was too huge. And once I set it smaller, it started to affecting the flame in the proper way. Turbulence. I can set turbulence to a really high value. and it starts to swirl and create all these vortices here. Yeah. Okay. And confinement, it's something about the same. Well, not the same, but just you get the idea. And advanced is, here we have OpenCL checkbox. This is useful if you have nice video card and you're not using Mac, because side effects, they said that they don't want to work with OpenCL and Macs because of some troubles. So this only supports Windows. And this is an acceleration. If you have some difficult simulation which fits in your video memory, then you can get a huge acceleration in the simulation time. So this will be way faster. All right, and here is a bunch of parameters, and most important, I'd say the advection type, because you can change it to something else, and this will be different. But this is really hard to make decisions when you change something, play simulation, then wait for a minute, and see the picture, then you forgot what you had a minute ago. So in one of the next lecture, I will show you the way how to automatically create the whole set of different simulations. For example, you want to test the different advection type, so you can set it up, set up your scene, click the render button and go sleep, and in the morning you will have the 10, 20, 30, it's up to your machine, different simulations. So I hope we'll have time for this. But for now, let's leave it like so. It's a different types of simulation. You can read it. It's read about it. This is absolutely mathematical stuff. So if you're really interested in, you can do this. All right, but I will leave it alone. That was a Pyro solver, and then it goes to merge, so it's merge everything, and the gravity force. I can turn off the gravity force in my simulation, and this will bring my flame to opposite behavior. So Pyro solver, simulation, combustion. If I turn off the gravity, this should go, the flame should fall down. Okay, wrong place. Alright, and the funny thing is that by default, the fire simulation comes without the gravity force, and you can find it here in Pyro solver, external forces, advanced external forces. So this sign tells that we exclude the gravity from simulation. So if I want to add the gravity, then I need to delete this, and let's play. Okay, not much changes are here, but there is a proof that the gravity is affecting the simulation. So if I select my gravity node and set the gravity to -98, for example, then play the animation, you see that it's almost not coming up, but it starts to fall down a bit. And just to make it even more visible, now you see that flame is just going down. Now we have gravity force applied to our simulation. Alright. That was all about Pyro Solver. In next part, I will tell you how to make your smoke and fire simulation collide with objects, and we'll show this stuff which I showed you in the beginning about volumetric light and yeah. So, all right, to show you how to make a collision between fire simulation and any object, I will create a new scene. Then I will set, let's say, a new object which will emit the smoke. And let's go to FireFX and select wispy smoke. So this is just fast, simple smoke. And again, I will hit D to bring my color scheme to dark one. So you can see this, turn on the grid. Alright, so here is my smoke. I will make it a bit darker, like so. And there is two ways to make a collision. First way is, okay, let's create a box first. And the first way is to turn this box into active object, rigid body. Okay, and let's turn it into rigid body. Right, so now you see the box is falling down, which is fine. And here we have RBD pin constraint. There's a few types of constraints, and but for now we're gonna use just RBD pin. So with my box selected, I click on RBD pin, and it's asking me to select dynamic object and press enter. So my box hit enter, and now I need to set the point in space where my pin will stay. So something like that. Alright, and now let's play animation, and you see that the box is just swinging back and forth, and there is no collision, which is fine, because it's necessary to go to Alright, so there is two ways to make your fire simulation to collide with objects. And the first way is to collide it with RBD object. Alright, so to start we need to create the sphere, for example, and then go to FireFX and assign a wispy smoke into the sphere, like this. So the smoke is coming up, and I will change my color scheme to dark so I can see it better. Alright, like so. Now I will make smoke more visible, and I need a bit more smoke to emit more smoke, and to do this I can scale up the source volume like so, so smoke become really dense. Alright, this should be okay, and I will set padding to 2 and max bounds is not clamped. So, like this. So the smoke is coming up by itself, and also I will change the dissipation to a really small number, so the smoke will stay longer in the scene. Yeah, like this. Alright, perfect. Now I need to create the object which will collide with this simulation. I will create a simple box, scale it a bit. Yeah, okay, something like this. Lift it up. And I will turn this object into dynamic object, like this. So now it's falling down, and the gravity force is affecting the box and affecting the smoke simulation. Okay, next I want to make this box swing back and forth, and there is a tool for this called RBD constraint. So with box selected, I click on this RBD pin constraint and hit enter. And now it's asking me to set my pivot point. So I click. Let's just move it here, maybe here. Alright. So now my box is swinging back and forth, and you see that it's pulling the smoke after itself, like this. So, yeah. So you can see that simulation is really affected by this box. Okay, I will enforce boundaries and like this. And minusing Y. So the simulation box will grow up only in the positive Y. This is really speed ups my simulation. Okay, so you see that it's affecting the smoke. Another way to make it collide with object, and not necessarily RBD object, is to use a new tool, and it appears in Houdin 12, I believe. Collide with object. So I will create a sphere again, apply the wispy smoke to this, decrease dissipation, increase source volume, so smoke is dense, change my color to black. Okay, and now I will create just any object I want, and let's do some simple animation. Expression, set keyframe, and let's say it comes into here. Alright, and here it must be something like this. Alright. Yeah, should be fine. Yeah, okay, I'll set it like this, like that. Alright, and now let's click on this collide with object, and it asks me to select fluid or fluid box to add collision to. So I select my fluid and hit enter. And now it goes through this, but as you can see, the smoke is not inheriting the velocity. Okay, and there is a way to fix it. I need to go to my torus object, which is my object which is colliding with the simulation. And here I need to go to velocity and object tab. And here I need to add object motion like this. These 2 points here is sending the Houdini to the upper level, to the torus, and the torus by itself has, on the scene level, it has animation. So, okay, now if I play the simulation, you see that it's affecting. And let's go back and change my fluid box. So padding 2, no boundaries, like this. Yeah, and the reason why it takes that much velocity is that here in torus object, in create collision volume, there is a scale parameter, which is I can set to 43, and this will take just 43% of the velocity. All right, something like that. I can set something to a small value. So now it's affecting, and smoke is following it, but it's not pulling it too far. All right, so this is how to collide your object with simulation. Next thing is volumetric light, which I promised you to show. And to make it work, we need to create a ground. And let's create a sphere. Very simple setup. And let's apply, let's apply candle to the sphere. There's probably gonna be a really huge candle, but that's fine. Let's scale the ground a bit. Okay. And now you see that there is a little flame. Okay. And to create a volumetric light, well, first of all, let's create a camera. Camera and render. So there is just this. Alright, and to create even better light, I need to select my fluid and then go to lights and cameras and click on volume light. Okay, and that's how it was, and that's how it looks now. Pretty huge difference. Alright, but here you can see a lot of noise. This noise comes from your rendering settings, and to eliminate this noise, you need to increase pixel samples. So if I set, for example, 15, which is pretty high, you see that there is almost no noise. The problem here is that render time is increased significantly because of flame. Well, let's finish this. Alright, so now picture is ready, and alright. Oh, this tool is always, yeah, okay, my fault. Alright, so there is a comparison of two images. This is 3 by 3 and this is 15 by 15, and the render time was really different. So there is a way how to fix this. You can go to your object network, and you can hide your flame. Like this. So the floor by itself renders really fast. Well, at least way faster than full image. And then you can render just a flame. So let's say this is our ground. I will pause the renderable, and now I will turn off the ground from rendering, and we'll set pixel samples back 3 to 3. Okay, and render now. So now it renders only the flame, and it's done. Well, sure, the quality of the flame is really low now, and resolution is really low, but this can save you rendering time. So this thing, nice, which is nice to know. Okay, that's probably everything about Pyro simulation. All these presets is basically the same, it's just in different numbers, so you can play with it by yourself. I can just show you, for example, the explosion. Alright, and the only difference is that few of the fields is animated like this. So source volume, and source volume is controlling the volume which is brought to the scene. Alright, so you see the value is changing, and the first explosion, then it's growing up again. And more flame, and this will go like this. So yeah, it's absolutely the same network here, all the same parameters, just different numbers. So feel free to click the numbers buttons and change the numbers. Alright, yeah, that's all for today. Thank you for watching, and see you on next lesson.